Hello friend, in previous video we have seen how Mohr circle looks like a circle and its derivation we have seen why we are calling it this is a Mohr circle we have seen it, and finally we have seen the circle equation and correlate this thing. Now we will see the some numerical problem on this. We will do some numerical problem. Before doing numerical, we will see the some sign convention in this. This is your Mohr circle. This is your sigma 1. This is your sigma 3, and this axis is your sigma s. This is the shear stress. This is your normal stress. Okay. So this is your sigma 1. This is your sigma 3, and now the upper portion is called the positive, and that is called the sinistral, and the lower portion is called the dextral, and this is your negative. Okay, now we will try to do a numerical on this. Okay, the numerical is we will draw a figure. Okay, and write it down. The question is, the figure shows the state of stress at certain point in a stressless body, that is your body. Here you try to different type of stress, sigma y, and this is not inside, this is the outside, that is a sigma x, and this value is 100. Okay, and its value is 20 megapascal MPa. This is given in the questions. So what we have to do in this question? This question is the magnitude of normal stress in x and y direction. In x and y direction, magnitude of normal stress has given this one and this one are 100 megapascal and 200 megapascal in y direction. The radius of Mohr circle representing the state of stress is, it is asking for the radius of the Mohr circle. So we have derived the all Mohr circle, and what is the Mohr circle? This is nothing but sigma n minus sigma 1 plus sigma 3 by 2, and overall square whole square plus sigma s ka whole square is equal to sigma 1 minus sigma 3 by 2 ka whole square. So this is your r, and in question this radius has been asked. This is the x square, this is the y square. So what will you do? Always in right side, sigma 1 is always in the right side. Suppose that this is the Mohr circle, then this side is a sigma 1. Okay, so from formula we will put, so here the sigma 1, what is the sigma 1? Sigma 1 is a 20 because it's a compression. So maximum, we know that sigma 1 is greater than sigma 2 and is greater than sigma 3. Then sigma 1 is because it's normal stress and going compression, so it is a positive, and sigma 3 is it is outside, that is tensional, and tension is always taken in Mohr circle 100. So minus formula minus 100. So what this will be? This will be upon 2. This is equal to 120 upon 2, that is here 60 meter. It's your answer. This is Mohr circle. Now we will see other thing. Now one topic is that states of stress. Now the first is that what is a triaxial? Triaxial is that when the sigma 1 is not equal to sigma 2 is not equal to sigma 3 and overall not equal to 0, then we will call it triaxial. All non-zero principal stresses are all non-zero. So this is your sigma n, this is your sigma s. So do these things, and this is your sigma 2, this is your sigma 3, all is the positive and non-zero. This is your sigma 1, this is your sigma 2, and this is your sigma 3. This is the Mohr. If 1 2 3 4, then sigma 1 is greater than sigma 2 and sigma 2 is greater than sigma 3. This is 3. So always in right side sigma 1. Now biaxial, second is the biaxial. What is the biaxial? Biaxial, in biaxial sigma 1 is not equal to 0 and sigma 2 is not equal to 0. Okay, but sigma 3 is equal to sigma 3 is equal to 0. Okay, then how it look like? This looks like this one. So this is your sigma 1, this is your sigma 3 which is 0, and this is your sigma 2, and here from here this is your sigma 3. So sigma 3 is equal to, this is the biaxial. Okay, we have more some states of this done. Now come to the biaxial we have done. Now the most important is the uniaxial. What is the uniaxial? So uniaxial, in uniaxial sigma 1 is not equal to 0. There are two types of the uniaxial compression and uniaxial tension. If we will see the in uniaxial compression, then this side, and if we will see in uniaxial tension, then we will consider this side. So consider in this side, then what will happen? Draw a circle. This is your sigma 1 which is not equal to 0, but sigma 2 is equal to sigma 3 is equal to 0. Okay, this is the uniaxial compression. Now come to the uniaxial tension. In uniaxial tension is sigma 3 is not equal to 0. Then well, this where go? This will go here, and draw a circle. Here sigma 1 and sigma 2 is equal to 0, but sigma 3 is something negative value. Okay, this is the uniaxial tension. This is your compression and this is your tension. Now we have seen the biaxial. Now we will see the hybrid type of suppose that this one, and draw. Okay, then here sigma 3 and sigma 2 is equal to 0 and sigma 1. Then sigma 3 not equal to 0 and sigma 1 is not equal to 0. This is also a biaxial type but hybrid. Some is the tension and some is the your this one compression. अभी हम now we will learn hydrostatic pressure. What is the hydrostatic pressure? Hydrostatic stress, not pressure. We will read the Mohr stress diagram. So its another name is lithostatic. So in hydrostatic, what will happen? Sigma 1 is equal to sigma 2 and sigma 3 is equal to sigma. That is the when this all these three things in equal, then what will happen? There will be a dot here, because this is a non negative, a non zero, and it's all is equal. Sigma 1 is always right hand side, so in anywhere the value is something from here to here. This is the hydrostatic pressure stress. Now what is the significance of this hydrostatic pressure? Hydrostatic pressure or stress does not change the shape of the object. Suppose that this is a circle, then when we talking about the shape, then this becomes your oblate or ellipse. No, this cannot be done by the hydrostatic pressure. This will be done by the deviatoric, and this is responsible for, suppose that this is your cube, then when you will apply this hydrostatics pressure or stress, then this become change in its size, its volume, not in shape. So hydrostatic pressure is responsible for its size, not in shape. Then in Mohr circle diagram, then which will be responsible for the this shape? This is derived from the your deviatoric stress. Deviatoric stress. What is the deviatoric stress? A deviatoric stress change in the object shapes, and this is the responsible from circle to ellipse, then this is from sphere to ellipsoid, then this is your deviatoric stresses responsible. Now responsible for change in shape in any object, that is called the deviatoric stress. And how deviatoric stress can be evaluated? Suppose that a plane is a AB, that is a AB plane, and we want to calculate the deviatoric stress, then it's for deviatoric stress, this is the total stress minus mean stress. And what is the total stress? Total stress is so deviatoric is total. Then how we will calculate the total stress, and what is the mean stress? These are two questions. So so in the case of the, when we will talking about the mean stress, there is a two plane, one is the 2D and 3D plane. So this will be, remember, when we will talking about the 2D plane, oh sorry, when we talking about the this mean stress, then mean stress is talking about the 2D, then it must be half. When we talking about the 3D, then it must be divided by the 3. But this mean stress for what? This mean stress for the hydrostatic pressure, hydrostatic pressure or stress, you can say. So this will be more clear with the, so what is the deviatoric stress of any sigma d of any plane in 2D plane or 3D? So it's a total stress, that is a sigma total minus mean. So deviatoric stress, then sigma total is equal to sigma deviatoric plus mean, and total stress is sigma 1 plus sigma 2 plus sigma 3. Okay, this will be remember. Then we, on the basis of this, we will try to solve a numerical. The question is that for the given circle, that is a given circle, okay, the first I will read the question and then we will draw. For the given Mohr circle under biaxial stress condition, the value of the deviatoric stress, the plane perpendicular to sigma 2 will be, then first we will try to draw this. The condition is the biaxial stress condition, and we have told you in biaxial, in hybrid type, this is the biaxial, and sigma 2 is equal to 0 and sigma 1, this is sigma 3. This is the condition of the biaxial. Okay. So question is that for the given Mohr circle under biaxial stress condition, the value of the deviatoric stress, the plane perpendicular sigma 2, the diagram has been given and asking for the plane perpendicular sigma 2 will be, sigma 2 is asking. So what will you do here? This is your diagram and this is the minus 20 megapascal. This is your sigma 3 minus 20 megapascal, and this is your sigma 1 is equal to 50 megapascal, and this is your sigma s, this is your sigma n. So mean stress, why this is a 3D diagram, so we will first calculate the mean because it's a ellipsoid, no? So divided by 3, not in a plane. So sigma 1 plus sigma 2 plus sigma 3, and here the sigma upon 3 is equal to 50 plus 0, because sigma 2 is a 0, condition is given by axial condition, and minus 20. Then what will this is your 30 by 3 is equal to 10. Sigma m is the 10, and so sigma ts is equal to total stress. Total stress is what? Total stress is the 0, because it is the, when you will read the question, be carefully. For the given Mohr circle under biaxial stress condition, the value of deviatoric stress, the plane perpendicular to sigma 2. So in plane perpendicular to sigma 2, then this will be total stress is equal to 0, and the sigma 1 we have calculated is 10, and now plus sigma deviatoric, so sigma deviatoric is equal to minus 10 megapascal. It's a plane perpendicular. So this is the answer. Now we will do some another question. You can say that is a concept. The deviatoric stress, we have seen that we have seen the deviatoric stress under 3D, that is stress condition, then the plane perpendicular to sigma 1 under uniaxial stress will be mean is, then the mean stress will be sigma n is equal to sigma 1 plus sigma 2 plus sigma 3 under 3D condition. You see, and here the in deviatoric stress under 3D stress condition on the plane perpendicular sigma 1 under uniaxial stress, then what will happen? In uniaxial, sigma 1 is equal to sigma 1, sigma 2 is equal to 0, sigma 3 is equal to 0. This is a non-zero. So by default, sigma 1, sigma m, and this is by 3, then sigma, then the deviatoric in the case of the uniaxial, what will happen? 2 sigma 1 upon 3, because this is your mean stress, sigma 1 by 3, and the total stress is equal to 0, and here the sigma 1 is your sigma 1 by 3, and this is your this what is this? This is your sigma deviatoric, and this is your not it, this is 0. But in the case of uniaxial, the total stress is equal to sigma 1, because all this is a 0, because this one is the 0. Then sigma 1 is equal to sigma 1 by 3 plus sigma deviatoric. Then sigma 1 minus sigma 1 by 3 is equal to 2 sigma 1 by 3 in case of this is the deviatoric stress. Okay, in the case of the deviatoric for uniaxial. So and the one question in your mind, how we will know the total stress? This is in come in your mind. This is very easy. What will you do? Suppose that this is your a this is your stress. Okay, then what is the total stress? Okay, divide this, and this is your sigma n. Okay, and this is your sigma f. So when stress is divided into two component, this is your sigma s, that is the sigma s, and this is your sigma n. Sigma s is here, then this is the sigma s, and this is your, then what will be the total stress? Then sigma total stress is equal to under root sigma n square plus sigma s square. This is the sigma total ts. Okay, in case of this, so this. Novel. Now come to the question, that is what is the irrotational strain? Irrotational strain. Principal axis do not rotate with respect to coordinate axis. Irrotational progresses definition. All other the general term principal axis do not rotate with respect to coordinate, then we will call the irrotational strain. Now come to the some graph. I will draw the some. This line is, this is your strain, and this is your stress. Okay, now when this is your straight line, then this is called a Newtonian fluid. After then you is called the dilation, and go increase stress, then this is your called pseudoplastic. And increase the, after some time, the when he continuously increase the stress, then this is called your Bingham plastic, which looks like your Newtonian fluid, but this is different from this. This passes from the your this things, dilation and the pseudoplastic, then Bingham plastic. So now come, we will see the fracture criteria in fracture criteria for, and how we will represent a fracture with the help of the Mohr circle. Now we will see the some fracture criteria, how fracture will develop, and when that fracture will develop, then how we can represent this through Mohr circle. The first thing, fracture criteria for extension for expression the fracture. So simply written is there the fracture criteria. Okay, this is your axis, and when the stable condition, then this will be here, and this is your the unstable condition. Okay, this is your sigma n, and this is your sigma s. This is shear stress, this is normal stress. When from here to here, then make this will the this, then stable condition, then this is the stable condition, and this is your unstable condition when going to this side. Okay. Fracture criteria for extension, just about to touch this axis, because here the extension, this is here the expression, this is the compression, the positive, tension is the negative. Now critical stress is this, when come to this hybrid type, when the sigma 3 is negative, then this is critical stress. Now fracture criteria for the normal stress, shear stress. Fracture criterion for shear fracture. then this is your sigma s and this is a sigma n. Then this will be sigma s is equal to sigma 1 minus sigma 2 upon 2 sine 2 theta we have seen. Okay, then come to this how shear fracture will develop. When its radius is changed, then what will happen? From here to here Mohr circle will shift, and this is your tangent line with the shear fracture envelope, and this is called shear fracture envelope, and this is a sigma n, this is sigma s. So when will this touch? Then this is called the unstable condition. Critical stage, when this will be touch here. Okay, when shear stress will increase, then this touch, then this is critical stage. Just after, then fracture will develop. When this cross, then the fracture will develop, and this is the unstable condition. Now come to the famous equation, that name is the Mohr-Coulomb fracture criteria. Now come to the name is Mohr-Coulomb fracture criteria. Then this equation is what? This equation is simple. Sigma s is equal to tan psi sigma n plus c. This is the equation. Why we are taken not a theta here? Because theta is already we have taken in the Mohr circle. We have sin theta and cos theta we have seen. Simply this equation is represented by this. This is your Mohr envelopes. This is a shear fracture envelope. And this is your Mohr circle. When this circle is increasing, then this is called your shear fracture envelope, and this is your sigma n, this is your sigma s. So at the critical stage, this circle will touch here, and the unstable stage, this circle will beyond this tangent line. Then here now we will see some understand through the equation. So wait just a minute. Okay, what is the phi? Then we will see here when draw this shear stress envelope, and this is your phi. Okay, and what is the c? C is your this where this cut here, this is the c, and tan psi is this one, psi is this, and sigma n is this, and sigma is this. Now we will see some numerical question. Is that for numerical is question in the given Mohr circle plot, in the given Mohr circle plot, sigma s and sigma n, 3 one, oh sorry, just I want to sigma n is the normal stress, sigma n, sigma is shear stress. This is your 3. This is your 2. This is your 1, and this is your 4. Then circle 1 is your triaxial tensile stress. Just see, triaxial tensile stress is sigma 3 is 0, sigma 1 and 2 is not 0, 2 and 0, and circle 2 uniaxial compression. Circle 2 is uniaxial compression, and circle 3 triaxial compression. Circle 3 is triaxial compression because it is positive. And circle 4 hybrid fracture. Circle 4 is hybrid fracture. This one is 4 is a hybrid fracture. Now we will do a question on this. Sorry about these things. Circle 2 circle 2 is your hybrid structure. Circle 2, when you go to the 4, that is the hybrid fracture, and your circle 3 is a triaxial compression because sigma 1 is not equal to 0 and sigma 3 is not equal to 0. Okay, because this is some tension side, there is a compression side, so that's why circle 2 is hybrid structure. Now come to this triaxial tension. In triaxial tension is this sigma 1 is not equal to 0 and sigma 3 is not equal to 0. So in this circle 3 the triaxial compression. So circle 3 is a triaxial compression. What will now as question is that question is what will be the radius of the Mohr circle in MPa for the condition shown in figure, in which horizontal stress is 80 MPa and vertical stress of 100 MPa. So condition is given here. So figure is given here 100 and 18 MPa. This is negative because it's a tension. It is given here. Horizontal stress is 80 MPa. Figure. So this is your sigma 3 minus 80, or sigma 1 is 100. Then sigma 1 minus sigma 2 by 2. This is your stress. Then sigma 1 is 100 and plus 80. This will be because upon 2, then 90 MPa. Now come to the some other question. In a ellipse, this 1, 2, 3 is called as a principal stress. Always remember. Then principal stress is when we will take the mean stress, mean of this 1 plus 2 plus 3 upon 3 for 3D or for 2D upon 2. Now another question is that question 4, consider a rock in lab under triaxial regime. The maximum principal stress sigma 1 and pore fluid pressure is increased by the same amount, while minimum stress sigma 3 is increased by double of the amount of the double amount. The new Mohr circle will be. This is the question. Again, I am reading here. Consider a rock in lab under triaxial stress condition under compressible regime. The maximum principal stress sigma 1 and the pore fluid pressure is increased by the same amount, while maximum stress sigma 3 is increased by the double amount of the new Mohr circle will be. Then what will we do before doing this question? First see the differential stress. Differential stress, what is the differential stress? This is sigma 1 minus sigma 3, because when is, if this is your sigma 3, this is your sigma 1, and this is your differential stress, nothing but your radii of difference. This is called the differential stress. Effect of the, now effect, come to the question, effect of pore fluid pressure. That is sigma 1, sigma 3 and sigma 2. That is sigma 1 dash is equal to sigma 1 minus P, sigma 2 dash is equal to sigma 2 minus P, sigma 3 dash is equal to sigma 3 minus P. This is the, do this and find the answer. Minus pore fluid pressure. That is the effect of this. Now this question has done. So in general, what is the effective stress? Effective stress is nothing but the stress acting on the plane. Then sigma 1 dash is equal to sigma 1 minus P, that is the plane, because of the plane fluid pressure. This is the plane fluid pressure. Then this has been done. Now come to the some other question is that consider the given Mohr circle diagram for 2D stress condition. Which of the following point represent the mean hydrostatic stressor and minimum normal stress? So diagram is given here. This is the diagram. This is the sigma n, this is the sigma s, this is a 2 1 4 and this is your 3. So question is that consider the given Mohr circle diagram for 2D stress condition. Which of the following principal stress represent the mean hydrostatic stress and the minimum normal stress? So mean hydrostatic stress, mean hydrostatic stress. So sigma 1, sigma 2, sigma 3 is equal in hydrostatic pressure. So this is 2D, then this is equal to half, and sigma 1 plus sigma 1 plus sigma 3 by 2. Here the sigma 3 is minimum normal stress, sigma 3 is 2, 2, this is the 2 value 2, and sigma 1 is the 4, then 4 plus 2 upon 2, this is 6 by 2, this is the 3. Now I think Mohr circle diagram has been finished. I have made 4, including this lecture video, 4 lecture. So another topic which is called Anderson fault theory, 1940. So Anderson fault theory what tells about? There are 3 types of faults based upon the relative movement on the hanging wall, that is normal, reverse and strike slip fault. Anderson 1951 predict a 60-degree dip for normal faults and 30-degree for reverse faults and 90-degree fault dip for the strike slip fault. So 60, 30, 90, remember, this is the Anderson general theory. Go to the Google and read about this in a detail. So this has been done. So figure will be this is your things, and this will be more clear when we will make some figure on this. 1951 lesson has made. This is 1 and this is 2. 60 degree, sigma 1, sigma 3. Okay, and this is the for Anderson. So normal fault is 60 degree and the reverse fault is your 30 degree and strike slip fault is 90 degree. So this is general theory of Anderson. So come to the things when we are talking about this type of the foliation. So in a foliation, suppose that what is the foliation? This is your grain size in a rock. Okay, when something stress has been applied and this is aligned in a direction, then you can say that this is the foliation. Then what will happen in the case of this? When sigma 1 is greater than sigma 2 and sigma 2 is nearly equal to sigma 3 happen, then foliation will generate. And suppose that a rock is this and this and convert in a ellipse and some lineation feature has generated, this is called the lineation. But in terms of the your this, what will happen? Lineation. In case of the lineation, sigma 1 is equal to nearly equal to sigma 2 and greater than sigma 3. When happen, then lineation feature will generate after the, and we know that lineation and foliation is developed deformed structure developed due to application of the stress. Now a famous question is come, what is the pressure solution? I'm just revising these things. What is the pressure solution? Pressure solution that given by the Dorney in 1972. Phenomena of dissolution of mineral under non-hydrostatic stress, then this is called a pressure solution. In non-hydrostatic stress means non-hydrostatic is when sigma 1 is greater than sigma 2 is greater than sigma 3, and in hydrostatic stress condition sigma 1, sigma 2 and sigma 3. Then in this case Mohr circle will be a single dot. Okay, so enjoy this lecture video. If you are new, please like, share, subscribe for supporting my YouTube channel. Thank you so much for watching, and we will meet some new things for upcoming video, so keep watching. Thank you so much.